I need to tell you a few things. When two triangles are congruent, each pair of corresponding angles are equal. That's a lot of things to write. If for some reason you need to state the reason over here. So you write this abbreviation, corresponding angles of, I don't want this symbol, please amend it, congruent triangles. Okay, so what this means is that if I tell you that A, B, C is congruent to X, Y, Z. If ABC is congruent to X, Y, Z, it means that this angle and this angle, they are corresponding angles and they have the same angle. This angle B corresponding to angle Y, they have the same angle. And obviously, the last one must be the same because angle sum of triangle, 180 degrees. Right? When two angles are the same, the third one must be the same, right? Make sense? Okay, yeah. So, in addition, we say that each pair of corresponding sides are equal. So please change this part. I don't like this. I don't like this symbol for congruency. Just change it to congruent. Okay. There was one. Okay. So what this means is that this line over here, AB, has a corresponding side, which is XY, and they have the same length. AC, XZ, they are corresponding sides, they have the same length, and obviously BC and YZ, they are corresponding sides, they have the same length. These are congruent triangles. Triangles, as we can see, has 6 parts. It has 3 sides and 3 angles. We just learned that as long as I show you that the 3 sides are the same, they are congruent. Yes? I don't really care about the angles. As long as 3 sides are the same, they are congruent. And I use the SSS congruency test. So let's see how we do questions based on this. Okay, example number 1. In this figure, how many triangles do you see? How many triangles do you see? 2, obviously 2, okay? AB equals to AD. They say that AB equals to AD. So as you read the question, just make little markings to help you. Then they also say that BC equals DC, BC, so 2 dashes, and DC 2 dashes. They also say that, BAC is 45 degrees, here 45 degrees. Show that triangle ABC is congruent to triangle ADC. Okay, without looking at the solution, how do we prove that 2 triangles are congruent? How did you prove that your triangles were congruent?
3 sides all same.
3 sides all same. Okay, we use the SSS congruency test. Alternatively, you can cut it out and paste up, see what the same. But in the exam, of course, we don't expect you to do that. You must use a test. Okay, this is the only test you've learned so far. Side, side, side. Do you have a side, side, side that are the same?
Yes.
Name me a pair of same sides.
AD and AB.
AD, AB, okay, same side. Another side?
AC, AC,
AC and AC and AC. Same side? Okay. What about the third side? BC and DC. Okay, very good. Now, please pay attention. I'm going to give you an approach that will always work for congruency questions. To show that triangle ABC is congruent to ADC, I will draw out the 2 triangles separately. The diagrams may be very complex. I will still draw them out separately because I want to get rid of all the other unnecessary information. So drawing them out, ABC is already here, ABC, ADC is also here. So I can choose to draw either ABC or ADC. In this case, I want to keep this triangle. I am going to redraw the triangle at the bottom, which is ABC. Okay, so this is what I'll do. Here I have ADC already. ADC. The triangle that I want to prove that is congruent is known as ABC. So I draw exactly the same in the same orientation. So I'll still go this way. ABC. Okay, so A over here, B over here, and C over here. And because they are congruent, well, the question asks you to prove it. So I can expect that they will be congruent. So the triangles must look exactly the same. So I'm going to draw exactly the same as this triangle. I'm going to photocopy it, and I'm going to put it over here. Okay, look. Here I've got my triangle ABC. Does my red triangle look like the yellow highlighted triangle?
Yes.
Do they look alike?
Yes.
Yes, because I deliberately drew it the same, exactly the same. Then the naming is very important. The naming, let's see what they said. A, D, C, right? Starting from A to D and then to C. The naming is important. So here we've got A, B, C. A, B, and C. Are they the same? Yes, this is my key to solving it. Once I have this, I'm now going to plug in all the information that I have. Question said that AB equals to AD. Well, look, AB and AD are the same, right? So it's over here. Okay? Then what else did they say? DC and BC are the same. So we've got BC over here. They are the same. Looking at this, my highlighted triangles, I'm going to highlight both of them now. Can you see very clearly where are the corresponding sides? AD must be corresponding to AB. Can see very clearly?
Yes.
DC must be corresponding to BC. And AC must be corresponding to AC. No need to guess. If we didn't have this, you might be thinking, oh, AD corresponding side, is it going to be BC? Or is it going to be AB? Is it going to be AC? If the sides are very different in length, then very easy for you to tell. But if they are not drawn to scale, then you have a problem. Which is why drawing this out is important for us. Yes?
So I thought there's a method where you use like ABC and equals congruent to ABC, right? So you just see the letters.
Okay, see the letter, yes? This is another way to check. A, B, C, congruent to ADC. The names are important, So A and A, B and D, C and C. In other words, AB over here, over here, AB and AD over here. You can use the names to help you. Likewise, AC for example, and AC. So AC and AC. You can use the names to help you. In fact, you can use it as angles also. Angle ABC. Where's ABC? ABC. This angle, which is this one, ABC, this angle is corresponding to angle ADC. ADC, same angle. You can go any way you like. CAB, for example. So CAB, this angle. So I started from last to the first to the middle. CAD, CAD, see, same angle. Okay, so the name will help you also. Yes, you are right. For sides and angles. Now, because I only have two sides that I've proven are the same, can I use my SSS test? Can or cannot? Cannot. I need three sides. I've got one side, two sides. Where's my third side? AC. Now, how do you prove that AC is the same? We call it common line. Okay, this is a keyword you need to know. It is known as a common line. AC and AC are the same because it is the common line, it's the same line. So in the solution, you see that they say, in these two triangles, AC is equal to AC. Write down the reason. Common line. Then, AB equals to AD. AB equals to AD. How do you know? How do you know AB equals AD? It was given in the question. So that's the next keyword, given. Okay? So write down the reason, given, and common side. So now, we have proven that three sides are the same. So we say that, hence, triangle ABC is congruent to ADC. And we say the test, SSS congruency test. Yes?
The common side, common line.
Common side, common line, same thing. Okay? Any questions? Who is following and thinks it's really easy? Okay, all of you should be thinking it's very easy, right?
Might not be easy.
Okay, let's try the next one. Try it one by yourself. I think you only need one. So, some things that are changed. I don't want this anymore. Don't want this, don't want this. something missing over here, and this one, change it to midpoint. Okay? Now next, part B. Part B says to find angle Y. Okay, angle Y is ACM, which is over here. Y. Okay? Angle Y equals to what? Don't just tell me 60 first. Angle A, B, M. Okay, what is the reason? Yes, because those two triangles are congruent. Be more specific. What do we see from the previous page? Okay, this one. So for some reason, sometimes you need to call out one of these reasons. Okay, so which reason should I use? Angle Y equals to angle ABM. Why? Why are they equal? What? Is it number 1 or number 2? Number 1. So what should I write? Each pair of corresponding blah blah blah? No, write down the abbreviation. Corresponding angles of congruent triangles. Okay? So they are equal, and therefore this must be 60 degrees, as shown in the question. Okay, so y is 60 degrees. And you see that every step I've got a reason. Reasons are important. Do not write down anything you like. For example, if it is given, means it's given. If it is a common line, then don't tell me it's given. Common line is common line. Given is given. There are several things. So some things you can also use will be found. Okay, sometimes found in part A, for example. Maybe in part B you are required to use something found in part A. So this could be a reason also. Given some other reasons could be when you're dealing with angles, alternate angles, parallel lines. Your interior angles, parallel lines. Corresponding angles, parallel lines. Angles in a triangle. What other reasons do you know of? Angles at a point. Adjacent angles on a straight line. Vertically opposite angles. Any more? Interior angles here already.
So equilateral.
Equilateral, what is equilateral?
Triangle is equilateral then.
Properties of a square, etc. Okay? So these are some of the things that you can use. After my lesson, you can take a picture if you want to. Okay. Besides the SSS congruency test, there are other tests that we can use. Now your next job is to draw a triangle with sides 7 cm and 6 cm. So point number 3. Have you already done that? Yeah. You have, right? Okay. Now next one, point number 4. Draw a triangle with side 7 cm, 6 cm, and then the angle between them must be 30 degrees. Okay? So now you are going to do point number 4. Or rather, where you can prove that two sides are the same and the included angle is the same, you will end up with congruent triangles. And that is our second test, yes.
Included triangle means
Included angle.
included angle means if you give me all 3 sides of the triangle, all angle is included.
It only makes sense to use the term included angle if I only give you 2 sides. Okay? Now, moving on to our third test. It is now the side angle side congruency test. Can you give me a name? Can you propose a name, a shortcut, an abbreviation? Yes, you're right. This is known as SAS congruency test. Okay? I'm not talking about this yet. Just talking about SAS first. Okay. Here, side angle side. If two sides and the included angle are equal to the corresponding parts, then the two triangles are congruent, SAS. Okay? How do we do this? Example number 2. So here I've got AE and BD, they bisect each other at C. What does bisect mean? What does bisect mean? Cut through? Okay. Divide into two equal parts. Okay? Bisect. So AB is 5. And name a triangle that is congruent to ABC. So ABC over here. This time they do not tell you which triangles are congruent. They ask you to name it. So you must use your eye power. Tell me which one is congruent to ABC. Which one is congruent to ABC? Is it EDC? DEC? CDE? Which one? DCE? So very difficult to tell, right? This is an example where the sides they look quite similar lah. Okay? So this is my approach. I will draw out the same triangle. So I want the triangle congruent to ABC, so I draw exactly the same. I try to draw ABC by myself. Okay? Does it look like ABC to you? Kind of lah. You try your best to draw it like ABC. So this one over here. Then I'm going to fill in all the information that I have. Okay? So there's a one stroke over here, so there must be a one stroke over here. Got two strokes here, so there must be two strokes over here. Okay? So can you tell me what is this point over here? Now we consider this triangle. Now if we map it over. What is this point over here? C. Quite clearly it is C lah. Okay, C. So what must be this point over here? D. So this must be D, and this must be E. So the triangle that is congruent to ABC must be, what is the triangle that is congruent to ABC? EDC. How you name it is important. Are you able to draw this by yourself? Are you able to do this sequence of steps by yourself? No. I'm sure you can. Okay? So, name the triangle that is congruent. After I've drawn it out, then the steps. First, we know that AC equals to EC. That was given. Next, we see that the angles are ACB, this one over here, is the same as ECD. What is the reason that these two angles are the same? Vertically opposite angles. Because, like what I wrote on the board, when you have two lines that intersect like this, these two angles must be the same. Vertically opposite angles. So now I have proven that, or let me just put it in green. Those things that I've already proven. AC equals to EC. So AC and EC are the same. Then the angles, this angle and this angle, proven to be the same already. Finally, BC equals to DC. BC equals to DC. Do I have two sides plus an included angle? Two sides plus included angle? Yes, I do. Therefore, I say that these two triangles are congruent using the is congruent. Basically, we don't need this. SAS congruency test. Okay? Because I want this line. I don't want the three strokes as a congruency.